Good morning. I'm going to talk about terminating and repeating decimals. We've already did that. However, we are going to convert these into decimals, rational numbers. So rational numbers, I'll explain what that means. That's a new word. We also can write a decimal as a negative rational number and then look at some absolute value with rational numbers. So if you see a term here that's been mentioning a couple times, rational. So what the heck is this word? Well, a rational number is any number in the world that I can write as a fraction. Any number. So look at all these numbers down here in this little picture here. All of these I can write as a fraction because I could write 8/10 as a fraction. I could write negative 1.444444. Oh, we know that 4 repeating is 4/9. Remember that one? How can I write this one as a repeating? Well, that'd be 5 and 2 repeating, so that'd be 2/9, right? How do I write -6 as a fraction? Oh, put it over 1, put it over 1, put it over 1, put it over 1, put it over 1. Guess what? All of these are rational. So any number that I can write as a fraction is a rational number. The only one that you will see as you get older is this irrational number, which is common one you'll see is pi. Pi is, there is no fraction in the world that is equivalent to pi. So we know what integers are. So your integers are the ones that are positive and negative whole numbers, but whole numbers are just positive. So starting at 0 all the way up. And then there's one more category, but that's as you get older. It's called natural numbers. But anyways, so we talked about earlier in another, I guess it was this chapter. Last chapter, how we show bar notation. So if you notice that the 12 is repeating here, the 12 and then another 12 and another 12. So how do we write it with bar notation? Just to review, you write the line over both because it shows that those both repeat. This one is a little different. I have 566 and 566. So again, I would put the line over the 5, the 6, and the 6 because not just the 6 is repeating because that 5 changed that. And then how do I represent the last one with bar notation? Well, I'm only seeing the 6's repeat here. So it looks like just this part right here. So I only put the line over the 6. So there you go. So guess what? All of these, you can write those as a fraction. So all of those are rational. Okay. So how do we convert these into a decimal? But again, don't forget the only difference is it's just extra practice. We just have a negative now. What always goes in the house? Always, always, always. The numerator, numerator, numerator. Always. So here's what I do. I bring over the negative. It doesn't have a whole number or anything in the front. So it's going to be negative 0. Something. Oh, Lordy. Okay, most of us know, I took care of that, so don't have to worry about it. Most of us know what 1/4 is, but I'm just going to show you again. Add a decimal, raise it up, add a 0. That's a 2. 2. Add a 0, bring it down, 5. So instead of it being 0.25, it's negative 0 and 25/100. So there you go. Okay, next one. Negative 5/6. So it'll be a negative 0 point something because it's not a mixed number. So I don't have to worry about anything in that 0 space. Okay, so it goes in the house. I took care of this. 5, 6 on the outside. So again, this is a good strategy to do what I'm doing right here on the side. Doesn't work. Add a decimal, raise it up, add a 0. 6 times 8 is 48. 2 left over, add a 0, bring it down. 6 times 3 is 18. And then I got a 2, and then I'll have another 0, and then you'll notice that this starts to repeat. Don't mind the phone ringing in the background. So this would be 0.83, but I would show this line over the 3. So this is what we call let me change my color here real quick. This is what we call, okay, this is a terminating decimal. And this obviously is a repeating decimal. Terminate means that it stops. After this point, it's done. There's nothing behind it. Whereas this, there is a bunch of 3s that we don't see that go on for infinity. Okay, I think you kind of get the idea. If this will let me go down. Same idea here. We should already know what 8/9 is. If it's out of 9, we know it repeats. So this should be negative 0.8 repeating, and that's how you would show that one. Again, 8, 9, you should notice that it repeats. Okay, moving on. Okay, same thing as before. Only difference is now I have a mixed number, a negative mixed number. By the way, these are rational because they can write them as a fraction. They're already in fraction form. So here's what I do. I take this bad boy right here and I bring it over. So instead of it being negative 0 point something, it's going to be negative 2 point something. I took care of that. So all I have to do is now change 1/6 into a decimal. So put the 1 here, 6 here, doesn't work. Add a decimal, raise it up, add a 0. That's 1. That's 6, 4, add a 0, bring it down. 6 times 5, 6. 6 times 6 is 36. And then I got a 4 here, and guess what? There's another 40. So my 6's keep on repeating. So this would be 0.16 repeating. So instead of it being 0.16 repeating, it's negative 2.16 repeating. Kids in the past asked me, Miss Edwards, can I make this a mixed number or improper fraction, excuse me? Can I do 6 times 2, which is 12, plus 1, which is 13, and then could I do it like this? Yeah, you'll get the same exact answer. So it's up to you. If you want to make it improper and then divide, that's fine. Just make sure it's whatever your numerator is goes in the house. Okay, next one. I have a negative 5, so I have a whole number part right here, so I took care of that. It's going to be negative 5 point something. So I put 2 in the house, 11 on the outside. So now I'm taking care of this. So whatever I get is going to go behind here. Again, repeating decimal for this one. I think it repeats. Add a decimal, raise it up, add a 0. It's 1, 9, 90, 8, 88, 2, 20, 1 and 8 and 1 and 8 and 1 and 8 and so on. How do I know? Because I started out with 20 here and then I had another 20 here, and then you should have noticed that it repeats. So this time it's now negative 5.18, and both of those numbers repeat. So there you go. Last but not least, let's just do one more. I already know what 2/9 is, so this would be negative 3.2/9. Remember, anything out of 9 repeats, so it's the numerator repeating. So this would be, oopsies, this would be your answer right here. And there you go. Okay, all of these are rational. All right, so now we're just going in the opposite direction. So connecting an old topic with a new topic. So let's see if we can do this. Write each as a fraction or mixed number in simplest form. Okay, so how do I say this? This is negative 0 and 6. What? Oh, it's in the tens place. So it'd be negative 0 and 6/10. Right? We don't have to say negative 0. So it'd be just negative 6/10, which then would be a negative 3/5 by cutting it in half. do not forget to bring Mr. Negative. That's why kids miss this. Okay, how do you write this one? Again, it's very easy. This would be, I would say it as -3 and, so I took care of that. That's the whole number, or the whole number part. And then how do I say this? That would be 12 what? Thousandths. So this would be -3. I could cut this into 2, which would be 6 over 500. Cut it in half again, which would be 3 over, oopsie, sorry. It would be 3 over 250. And then I'm done. So same idea. Only difference, guys, is the negative. Big whoop. No, nothing really different there. Okay. And then last but not least, let's go ahead and look at this one. This would be -5 and 85 hundredths. If you simplify it down by cutting into 5, you would have -5 and 20. That would be 20. And then that would be a 1, 3, 17/20. Okay. Go ahead and pause the recording. Okay, so let's look at the next problem here. All right, so this is absolute value. Looks familiar. However, these are rational numbers. So we're going to find out how far are these numbers from 0. So guess what? Don't think about it too hard. So absolute value means how far that number is from 0. So what do you think the answer would be for the first one? If I take the absolute value of -2 and 3/10, which I could also write it like this, -2 and 3/10, right? It's rational. I could write it as a fraction. How far is that from 0? You said 2 and 3/10, or wrote it this way. Guess what? You are correct. It is 2 and 3/10 away from 0. Okay, 4 over 13. It's a rational number. Why? Because I could write it as a fraction. It is already a fraction. So how far is 4/13 from 0? 4/13. That's it. And the last one, what's the absolute value of -8 and 7/11? Again, that is a fraction, so it is rational. Therefore, if I figure out how far that's from 0, it's -8, or sorry, it's 8 and 7/11 far from 0. So how far is this one from 0? It'd be 5 and 73 hundredths. Or you could write it like this. Technically, I would not mark it wrong. Same thing with this one. Absolute value of -1/4 is 1/4 from 0. However, I would not mark it wrong if it was this, because that's equivalent. So again, just how far is that number from 0? Last but not least, we're just going to go ahead and look at some of the questions involving word problems with repeating decimals or terminating decimals. Oh, I gotta stop yawning. Okay. All right, number 1. Of 9 students surveyed, 4 said they prefer exercising in the morning rather than the evening. Miss Edwards likes neither, but that doesn't matter. Okay, express this fraction as a decimal. Use bar notation if necessary. So what is the part? So I have a 9 and a 4. Well, 4 is the part because 4 out of 9 prefer to work out in the morning. So write this as a decimal. So if you already know this, you should know that this is 4 repeating. If not, put the numerator in the house, denominator on the outside, add a decimal, add a 0, and then keep on going, and you should notice that it repeats. So the answer here is this one. Okay, next question. Again, another survey. So survey is taken about kids' favorite color. Write a fraction representing the number of students who like blue. Okay, so we want the blue kids. Not physically blue, but they like blue. Okay, so how many are like blue? Okay, that's the part, right? So part is the blue. So 20 out of the whole. Well, that means everybody in together in this whole survey. Well, this is 20 and this is 20. I try to like think of numbers that I can add quickly and easily together. So 20 plus 20 is 40. So 20 out of 40 kids, which is 2/4, which is a half. So half of the kids like the color blue. So how do I write this as a decimal? Well, you should already know half is equivalent to 50 cents or 5/10 or 50 hundredths. Technically, this is the same. Or you could put numerator in the house, denominator on the outside, whatever you like to do. There you go. So the answer is 5/10 or as a decimal. These are both representing terminating decimals. Last one was repeating, but they're all rational. Like I said, everything up to this point. Okay, question a little different. Be careful here. There are over 2,700 species of snakes in the world. Over 600 species are venomous. Not poisonous, venomous. Write a fraction of species that are not venomous. Okay, first of all, how many total species are there? Whole. Whole is the total, so how about 2,700? Now, we want the ones that are not venomous. Well, this 600 are. How do I find how many are not? How would I do there? Well, if you think about it this way, if I have 2,700 and I subtract the 600 that are, I have 2,100 that are not. So I have a lot of species of snakes that are not venomous. So they won't hurt me. I will be safe there. So in this case, this is super easy to simplify. Got a set of zeros. So I have a 21 out of 27. So for every 21 snakes, for every 27 snakes, only 21 of them are not venomous. So there's only 6 that would be venomous out of 27. So that's pretty good chance of not getting a poisonous snake. If I asked you what percent that would be, you could do a proportion, right? Figure out what it is out of 100, or you could divide. Let's see if it's like 80 or 90%. Let's just do this real quick. Let's see. 27 times, well, I want it to be 90% chance of not getting hurt, right? Because I wouldn't want to be hurt. Let's see, 18 plus 6 is 24, too much. 80% range, 56, 16, 16 plus 5 is 21. We're in the 70% range. So this would be about 70%. Still not bad. Still not bad, but not bad. But better than it being the other way around. Okay, well, you don't have that homework, so don't worry. Because you don't have a textbook. So that's all for this lesson. So if you have any other questions, feel free to pop back into Zoom, and I shall see you tomorrow. Technically Monday, but whatever, tomorrow. All right, bye.